Hello everyone, my name is Dominic Preuss. We're about VillageSQL and also extensions for MySQL. So VillageSQL was a company that was started by myself and Steve Sharippa, who is one of the tech leads for Bigtable and Colossus at Google. And so we've been working for the last couple of months on building this company. The company is focused on MySQL and things we can do. So people that we brought, so I'm here, obviously Tomas is here, many of you know him from his time at MySQL, and then Dan Bentley is also from the team. So we're 7 people, the 3 of us are here to answer any questions you might have. So we've talked about this a lot. The adoption and the perception of MySQL is something that has been stagnating over time. Everyone's seen this graph, this is DB engines. But the real question is why? And so when we started the company, we asked ourselves this question. So I spent many years at Google, I spent a couple of years at Amazon, and what we were seeing was that all of the hype and the conversation was happening about Postgres, all the companies were being created in Postgres, but the majority of the usage and the really large deployments was all in MySQL. And so the question was why? Why was this happening? And so we came up with the thesis that there's 2 big reasons why this is happening. So the first one is the governance model. Peter, you spent a ton of time talking about governance and the perception of how Oracle is interacting with the community versus how Postgres is a big issue. The second one, Peter, I completely stole from you, which is the permissionless innovation. This came from the summit, and we talked about it in terms of the ability to innovate without talking to the community, and permissionless innovation is the best way. So I'm happy to credit Peter with that. So what? So VillageSQL's mission is to drive innovation in the MySQL community. How do we address these issues from a governance point of view, from a extensibility point or permissionless innovation point of view? And so we've been working on this, and this is the first time we're really talking about it amongst the MySQL group. So we're excited. So what does permissionless innovation mean? If you look at the 2 kind of best examples out there right now, is DuckDB and our friend Postgres. So DuckDB, there's over 149 extensions. This is the most modern implementation of an extension framework. If you haven't played with it, it's great. They've done a really good job of separating the channels and what comes from core versus community. Examples are Parquet, file support, spatial, and they have Postgres plugins. Obviously, Postgres, if you haven't looked recently, there's over 1,000 extensions for Postgres. There's obviously those that are accepted in the project that are in the contrib directory, but then there's also the community. And obviously examples are pgvector, PostGIS, pgcron, there's a bunch. The majority of the usage falls into probably 20 or 30 extensions, but there's over 1,000. So whatever you need, you can get. And so the first question is, why did we build extensions? Why didn't we use plugins or components? So when we looked at plugins and components, basically there just wasn't enough, there weren't enough hooks for us to do what we needed to do. So extensions are designed very much similar to what you see in DuckDB and Postgres. So custom types, custom functions, custom indexes. In the future, the ability to overwrite the query plan, the query execution, and it all sits outside of the MySQL core code base. So the big issue here is maintainability. So if we were working inside of plugins and components, then obviously that's a moving train. As Oracle launches new things, we need to keep up with it. By putting everything into an external extension framework, it allows us to keep that code base separate. So right now this is built against 8.4. We'll backport it to 8.0. We'll move it forward to 9.0 and whatever the LTS is, the 9.7. But the idea is that it's very surgically inserted into the MySQL code path so that it's easy to maintain and to port forward and backwards. So what does that actually look like? So I pulled the stats from last night. So what this looks like is within actual MySQL code base, there's only 2,400 lines of code. So we've tried to be as surgical as we can for changes that actually go into the MySQL code base. The framework itself is about 14,000 lines of code that sits in the VillageSQL directory outside of the code base. We've deleted a few things that we've replaced, but for the most part, it's a very surgical entry point into MySQL. Now, this is independent of all of the extensions. We've also built about half a dozen extensions, and so all of those sit in separate GitHub repos. They don't sit in the main source tree. So this is independent of what's been built from the extension frame, from actual extensions. All right, so we were hoping to get everything launched by this week. It didn't quite happen, so this is going to be a preview of the alpha release. So either next week or the week after, we'll be launching an alpha version of the framework. So GitHub repo, totally public, GLP2, GLP-v2 license just like everything else. We'll also launch separate repos for a handful of extensions that we'll talk a little bit about today. The alpha has custom types and custom functions. Custom indexes is a harder lift, and so that'll go in the beta version, which we'll talk a little bit later. But we'll kind of talk through what we built today and kind of what it looks like for a developer. And I'll hand it over to you.
Okay. Thank you. So just a small digression. I've been sort of on the inside of MySQL for many years, and I've struggled, or my team then has struggled very hard with like how do we take in contributions from the community. It is very hard. It's not that we didn't want to when I was there. I sit with like day-long meetings with Facebook. They have like 200,000 lines of code that we want to take in. It's just very hard to take in code from the outside into MySQL. And always it is the discussion that, okay, we'll take it in, we'll take this piece in, but we will change it a little bit because it doesn't quite fit the way we want to do it in the future. But it's going to be in the next version, 9.7, or some future version. And that, of course, doesn't work for the customer or user because they want it now in the version that they're actually working on. So that's one of the reasons why I think an extension framework like this is really valuable. You can get your extension now with the version that you're working on. So I think this is going to be a huge benefit to the MySQL community, something like this. So we want to make it really simple for the user. So install extension. And in this case, you're showing VillageSQL, vSQL UID, but the example later is going to be complex. UID is one of the extensions, complex is one of the extensions. It's going to be more extensions coming down the line. So this is what you see from the SQL side. And when you then use that extension, you just use it like any other type when you create. So you'll have a new complex, or in this case, a UID type that you can use, and it will do whatever you program it to do. And so in this case, it will, for UID, it will of course check that it validates that it's the correct UID and so on. So we'll have vector, it's another one. So another one thing that we don't have that we identify that is an issue. Of course, you need line spacing because there might be clashes with other vector implementations that we implement this, and this is not something that exists today very well in the plugin components and function framework. So this is an important thing in the extension framework. So the structure of the extensions, you have a manifest file where you basically have a directory structure. So the first version that we're coming out now is going to be a completely C-based extensions. So in the future, we'll be looking at more variants, but the initial one will be C-based. So you have a structure on your file system where you have like the name of your extension, you will have the source code for it. If applicable, you will have some test cases to run it, just like if you're familiar with the test structure within MySQL test framework, similar CMake files and the manifest.json that tells you like what it contains. It will come with like ready-made CMake things, so you don't have to write your own complete CMake yourself to make it as simple as possible for the user to write their extension.
So very quickly, one of the big things that was important about this comes up all the time, is the dependencies against the MySQL code base. And so within the extension structure, there's a separate header file that you can basically link into, so you don't have to link into the entire MySQL code base. And so what we've done is we've put an actual shim between the MySQL code base and the extension space. We call it an SDK, but it's really just a set of APIs that you can use to go against. And so this basically gives you that clean separation between the two. So we can make sure that the header file stays stable, even if the underlying MySQL internals are changing. We'll keep that API stable so that it's stable across versions.
Thank you. And the manifest.json is similar to what you see in, for example, PostgreSQL extensions. They are control files. You give the extension a name, a version, some sort of description, and what license you have it. I mean, who authored it, and so on. So pretty standard. So this is how you then, in the first release, will author your extension. So you will give your extension a name, or in this type it's a type extension. So you give your type, and then this example is a complex. So you give it, you make the type, you tell it how you want to store it, how much storage space, this is something that MySQL needs internally, how you convert from your binary format to your string format, how you go from your string format to your binary format, and how you compare two entities of this type. So I already said this, you need to have the conversion functions for basically the types. What you need after that is also functions that operate on this type. So typically you want to add complex, you want to subtract complex, you want to do multiply, and here, for the purpose of example here, this is divide, and you want to be able to specify the type of the parameters. What it returns, and how many arguments it takes, and what are the types of the arguments. So this is something that you don't do easily in the current functions that is provided by MySQL today. And then of course you have to provide it with the C implementation of like how is this done. Go ahead.
The VEF entry point.
Yeah.
This is VillageSQL SDK.
Yeah.
Okay.
Yeah.
So VEF stands for VillageSQL Extension Framework. And so this is basically the call out. If you go back up to the structure one, to keep going. One more. So basically this is the call out that's in the extension.cc file. So that's where you put all of your C implementations. That call out is what does the definition. As Tomas was saying, in the future, we also want an ability to define these things in SQL or some other structure. But in the first version, it's all in C. So that all lives in the .cc file. And that's just, again, that's the SDK or the API service that we're exposing.
So if you think about implementing a function like divide, one of the things that you run into handling errors or warnings, like a divide by 0, for example. You want your functions to be able to throw a warning, just like a native type would do if you divide by 0. That, for example, is something you can't do in the current functions that you can, or UDF structure. So we extend the current UDF. Right now we're piggybacking on the current UDFs, but we're extending it with more capabilities, and we're calling them Visual SQL defined functions, VDFs. So we'll talk about future roadmap.
Yeah, so this is what we've been, what's built and will be going on in the next week or so. We also are working on custom indexes and a reference vector search implementation that allows you to search, allow you to store those indexes outside, well, inside of InnoVV, but outside of the existing types. And so that'll be another month or so afterwards. After we get out the beta, we're going to be doing a bunch of testing, production work, hopefully working with folks in the community to make sure that it's production ready, and then we'll go to a GA. So the alpha is going to be 0.0.1, the beta will be 0.1.0, and then when we go to 1.0, that'll be the GA when it's actually ready for production workloads, in our opinion. But we're going to be working with a number of folks to run tests. For example, benchmarking. So we started running benchmarking against this. You actually been doing most of it. There's very little overhead, so if you aren't using the functions, the actual changes that we made are negligible amount of overhead. Obviously, if your extensions are slow, that's going to slow down the query speeds. But in terms of the overhead of the framework, it's basically negligible right now. So just in terms of next steps, so if folks want to be notified when we're going to launch this, again, hopefully it'll be next week or the week after, just put in your email address here. You'll get the announcement email that'll come out in the blog, and will be linked to the GitHub repo for the server, GitHub repos for each of the extensions. There will also be an extension framework template repo that you can clone and start to build your own extensions. The whole point of this is that you can take an extension, the template, build an extension, publish it on GitHub, and people can start to use it immediately. Obviously, you have to build it and distribute the bundle. We call it the VEB file, the VillageSQL extension bundle. That file needs to go into the extension directory in MySQL, and then you need to install it. But once you publish it on GitHub, basically, folks can start to use that extension immediately, which we think is kind of the key thing that needs to happen to allow a lot of hacking and innovation and working that people want to do in the MySQL space.
Yeah, I mean, important here also. We want to have engagement here from the community as soon as possible because we want the feedback on what we're doing, right? So we're still early. We want the feedback. So any changes that we want to make or need to make based on your feedback, the sooner the better, right?
Yeah. So it'll be a public GitHub repo. It'll have issue tracking. It'll have discussions. We'll do all of those discussions in public on the repo. And so we do want this to be a place for the community to talk about things that they want to do and things that they need. We're working with a couple of design partners right now that have large deployments, but we would love to get a lot more feedback and a lot more people playing with it. And so, the ask for us is really to the community, this community, to help us make sure that we're going in the right direction and we can provide something that's helpful. There have been so many talks today, MyVector and a bunch of things that hopefully we can help accelerate the innovation and accelerate the development that people are doing with those things.
And the commitment around the tracking fork, I mean, we are going to be fully compatible. I mean, we're not going to make any changes to the user experience or anything in MySQL, right?
Yeah, exactly. So it'll be a drop-in replacement. So right now it's based off 8.4.6, and we'll rev that before we release. And so this will be a binary that you can drop into your existing deployments. And so there's no functional changes or anything. All of our if you aren't executing a extension, then it's just the straight MySQL code, no changes. The whole reason that we've done this is that the community will be able to submit changes to the binary as long as they don't affect compatibility or maintainability. If there's anything that you want to change that affects those, then we will push you into the extension space and you can do those changes in the extension space. But the whole point is that it has to be a drop-in replacement for MySQL so that there's no reason why anything that's been built against MySQL won't continue to work.